Today I'm going to talk to you about function ref, which is a non-owning reference to a callable, which is a proposal that's been discussed in Albuquerque. So everyone knows that C++ is getting more functional. And by that I mean, in C++ 11 we got Lambda Expression and CD function. In 14 we got generic lambdas, 17 const expr lambdas. So we definitely are putting a lot of effort into standardizing features that make functional programming easier. And also everyone knows that Lambda expressions are just syntactic sugar for the definition of anonymous closure types. So when you type something like this, I'm going to try something magical, if it works. Yep. OK, when you try something like this, which is just a lambda that prints to a CDC out, the compiler generates a struct like this one, where we have an implicitly const operator call that returns auto by default and contains the body of the lambda. And even though they are just syntactic sugar, they kind of change the way we think about code. Because now we can write high-order functions in a very easy manner. Let's say we want to benchmark the execution of some other function. Then we can just create a lambda called benchmark that takes a function f, then we start some clock, we execute f, and then we return the elapsed time from the lambda. And if you have some algorithm that you want to benchmark easily, we can just pass it as a higher-order function through a lambda in this case. So for example, if we want to benchmark some algorithm, we can just pass it to that higher-order function, and we'll get back the time. And another thing I like to do is wrap stuff that's supposed to be synchronized and thread-safe into this kind of synchronized wrapper, which only allows thread-safe access through a higher-order function. So if you want to access the widget inside this synchronized wrapper, you need to provide a function to access that will operate on the widget. And this guarantees that it will be locked or atomic. So it depends on the implementation of synchronized. On the other hand, if you use lockguard, you might forget to take the lockguard, and that's not good. So Lambda expression make high-order functions viable in C++ because before that you would have to write structs which have a lot of boilerplate. And high-order functions are those functions that either accept a function as a parameter or return a function from their own body. So it's basically what first-class functions can do. So what options do we have to implement higher-order functions? The first one is pointer to functions. So for example, operation here takes some f, which is a pointer to a function returning int and taking two ints, and then invokes it with 1 and 2. So this works with non-member functions and stateless closures, but it doesn't work with stateful callable objects. So if you have a lambda that captures something, you will not be able to pass it to this function pointer. It also has a small runtime overhead. If you play around in Godbolt, you'll see that in the same translation unit, this is easily inlined by the compiler. And it's constrained with an obvious signature, because you can say that it's returning int and taking two integers. And if you pass something that doesn't match this signature, the compiler is just going to throw an error, and it's going to be easy to detect what the problem is. Another alternative is template parameters. So in this case, operation is a template function that takes some f, it should be f as well, by forwarding reference, and returns a trailing return type, which is the decal type of how I'm invoking the function, which is by forwarding f and passing 1 or 2. So what I'm trying to do here is saying that operation is valid for every f that can be invoked with 1 and 2. So this works with any function object or callable if you use a CD invoke, and it's a zero-cost abstraction, as everything is very transparent to the compiler and can inline everything aggressively. Hard to constrain, but might degrade compilation time, and you need to define it in the header. So it does all the usual template issues. Then we have a CD function, which works with any function object or callable out of the box, but it has significant runtime overhead, mostly because it's hard to inline optimize for the compiler, since it needs to check whether or not it has to allocate, to use the SBO buffer, and stuff like that. It's constrained with an obvious signature, so that's good, but it has unclear semantics. If you instantiate this thing with an std ref, then it has reference semantics. If you instantiate this thing with a function object or a callable, then it has owning semantics. So it's kind of weird. You don't know what you want to do by looking at the signature. And then we have function ref, which is what I proposed and was discussed in Albuquerque. And it's basically string view for callable objects. So string view is a non-owning reference to something that's a string, right? It can be a sys string, a cd string, or whatever. Function ref is a non-owning, lightweight, let's say, reference to any callable object that matches a particular signature. So in this case, this operation accepts any function object or callable that takes two ints and return an int. And this works, as I said, with any of function object or callable. It has a very small runtime overhead. It's comparable to function pointers, so it can be completely inlined if it's in the same TU. It's constrained with an object signature in the type, and it has clear non-owning semantics. So if you pass something to it that's going to die, it's your fault. You need to make sure that the lifetime of the object referenced by the function ref will live at least as long as the function ref itself. So I proposed this to Library Evolution Working Group, and it was discussed in Albuquerque, and I got news yesterday, and they like the proposal. They just want to change some of the semantics. Like, it has an empty state right now, but they want to get rid of that. So I'm optimistic that in a few revisions it's going to be in the standard. And if you're interested in seeing how it works, this is pretty much it. I'm going to try some other magic here. OK. So what we do is we have a template class that takes a signature, and then we specialize it in order to extract the return value and the arguments from that signature. Then the implementation is having a pointer to some callable object that's completely erased as void star, and a function pointer to the operator call of that object, which is erased as a function pointer that takes void star as the first argument and the bunch of arguments that we defined before as the rest. And this void star that you see here, this is going to be the pointer that we store to the callable. So in the constructor, we take any callable by forwarding reference. We store its address in the void star pointer. Then we set erase function to a new lambda, which is stateless, so it can be implicitly converted to a function pointer that takes the pointer to the callable as the first argument and a bunch of arguments later, and returns our return type. And in order to invoke it, we reinterpret cast the pointer that we're passing as the first argument to f, which we have available here in the constructor, and then forward all the arguments to the invocation of that pointer. And when we invoke our function ref, all we do is go through erase function and pass the pointer. And this is it. This is the entire implementation, which is available on one slide, except obviously some constraints here that are required to avoid hijacking the copying and movie constructor. And yeah, that's how it works. So if you're interested in seeing more, the proposal is available here at this link, and it contains an analysis of the cover techniques, specification and synopsis of function ref, and also existing practice, which is actually, there are actually a lot of implementations of function ref already, and one in an LVM, one in Folly, one in GDB. So this is something that people use and want. And also some possible issues and open questions. And this also was kind of inspired by an article I wrote on my blog, because too many people were using std function as parameters and was bothering me. So I wrote this passing functions to functions article that gives pros and cons for each technique, and tells people how they should implement higher order functions depending on their needs. So thank you. I think we have time for questions, so feel free to ask.